Hello everyone. I welcome all of you on this massive open online course, and today I will cover metamorphic rocks, their nomenclature, texture and protolith. The name of the most metamorphic rocks are based primarily on texture, structure and mineralogical characteristics. The most striking features which stamp a rock as metamorphic is its fabric or structures and texture, which is the foliation oblique lineation. Therefore, the widely used rocks names are schist or gneiss. The group name is also modified by a term which indicates a specific textures, for example, orognesis. The group name can be further modified by the name of an index mineral placed as a prefix to the group names. For example, garnet schist. The name of the index minerals or key minerals indicates a specific condition of metamorphism. If a rock is almost monomineralic, it may be named after the dominant minerals, for example, quartzite dominated by quartz, marble by calcite or dolomites, serpentine almost entirely made of serpentine and the like, but most rock contain 3 or more minerals. These minerals are listed with hyphen between them and placed in order of increasing amount, that is model percentage, before the group name. In the given example of garnet, chlorite, hornblende schist, the mineral hornblende must be in a maximum amount than chlorite or garnet. And in cordite, garnet, sillimanite, biotite gneiss, biotite is in maximum amount while cordite is in the least amount. While an index minerals indicates a specific metamorphic condition, the abundance of principal metamorphic minerals indicates a rough guide to rock composition. In the two examples in the preceding sentence, the first rock indicates parent of basic composition, while the second indicates peltic parents. These criteria are basic of field and or laboratory studies of metamorphic rocks. In other nomenclature, some terms invoke genetic assumption and employ such prefix such as para and ortho, which are used respectively for sedimentary and igneous protolith. Para gneiss and ortho gneiss or para amphibolites and ortho amphibolites are the term used in this sense, but it is indeed difficult to resolve unless more intensive geochemical studies are undertaken. Hence, the genetic terminology is avoided in naming a rock. If original protolith parent rock is still clearly recognizable, we attach the prefix meta to the rock names. For example, metabasalt, metagranite, metachert, etc. Thus, we see that there are 4 main criteria for naming metamorphic rocks. First, nature of the parent materials. Second, mineral assemblages. Third, rock texture. Fourth, any appropriate spatial name. Common metamorphic rocks on the basis of structural terms and mineralogy. The common names of metamorphic rocks are slate, a very fine grained rocks characterized by slaty cleavage. In the field, a slate can be distinguished from shell by the absence of earthy smell. when we moist it with our breath. It develops from cell and tends to cleave into thin, flat sheet. Slate is the lowest grade metamorphic rocks that form from a cell parent rocks. Slate is made up of microscopic mica minerals, usually muscovite. These are flat minerals that are aligned parallel to each other. This orientation of the crystals causes slate to break easily in one direction. This property is called slaty cleavage. Cell is made of clay minerals, and most clay are not very stable under high pressure and temperature. As cell begin to metamorphose, heat and pressure cause the clay minerals to slowly recrystallize into flat mica flakes. Slate breaks in a preferred orientation because the mica crystals are flat and tend to break along the flat direction. During metamorphism, the micas grow with their flat dimension oriented at right angles to the maximum pressure. This process lies all the micas up and gives slate its characteristic cleavage direction. Slaty cleavage is one example of the metamorphic texture called foliation, which means layering. The color of slate depends on the chemical composition of its parent cell or mudstone. Red slates are rich in hematite and iron oxide. Green slates contain a significant amount of chloride. Purple slates are stained by manganese oxides, and black slates contain carbon-rich organic materials. Phyllite, a fine-grained and very finely schistose rock that develop from slate, the foliation S surface of which is due to the presence of sericite. The cleavage surface so lustrous seen due to coarsening of mica, sericite, muscovite, and chlorite. The schistosity may be thin segregation quartz-rich bands which may alternate with micaceous bands. Phyllite is a low-grade metamorphic rocks consisting mostly of fine-grained micas, but the mica crystals are larger than those in slate and are large enough to be just barely visible to naked eyes. Phyllite typically developed from slate at temperature around 300 degrees centigrade. Other common minerals found in phyllites beside muscovites includes chlorite, green, graphite, dark gray or silvery, and sometimes garnets, red or brown. The characteristic wavy, layered, glittery texture of phyllite is another example of foliation in metamorphic rocks. Schist, a strongly foliated and commonly lineated rocks which can be easily split up to plates of few millimeter thick. The schists are usually medium to dark colored and consist of lamellar minerals like micas, chlorite, talc, or prismatic minerals like amphiboles and selimanite, etc. If schist contains more quartz relative to the sum of the phyllosilicates, which collectively are nearly 50%, the rock is called quartz mica schist. Low modal amount of plagioclase, nearly 10% in schist, distinguish them from gneiss. Schist is a medium grade metamorphic rocks that can come from a variety of parent rocks. Although The most common cysts are formed from cell parents. This means that they comes through a transition from cell to slate to phyllite to cyst. Cyst is characterized by an abundance of coarse mica minerals grains such as muscovite, biotite, and chlorite. The mica grains are large enough to be seen without magnification. Usually, they can be flacked off with a fingernails. Cysts display cystose texture, which is similar to phyllatic texture, except that the minerals grains are coarse enough to be seen with the naked eye. Cyst typically shows little or no segregation of minerals into discrete bands or layers with metamorphic minerals. Especially garnets are commonly found throughout cyst. Greenstone or green cyst, green colored low grade metamorphic rocks dominated by the presence of chlorite, actinolite, and epidote minerals that may show cystose textures or non-cystose textures. To qualify, the rocks are green cyst or greenstone. These rocks form mainly from metamorphism of a basaltic igneous parent rocks and is marked by the presence of chlorite mica, which gives green cyst its characteristic green color. Blue cyst, a metamorphosed mafic rocks containing large quantities of glaucophene, blue amphiboles, and has a pronounced cystosity. Gneiss, medium to coarse grained foliated metamorphic rocks marked by bands of separated minerals, usually alternating light and dark colored minerals, known as gneiss structures. Gneiss is a high grade metamorphic rocks only formed deep in the crust beneath active mountain chains such as volcanic arcs at subduction zones. Its prime distinguishing feature is gneissic textures formed by segregation of minerals into distinct and commonly colorful bands. It splits parallel to a surface, generally along mica or hornblende layers, into plates or blocks of few centimeters. The term is almost exclusively used for rocks containing abundant feldspar and quartz. Unlike cyst, the gneiss contain bands that are dissimilar in both texture and mineral composition. A field-based classification is on the basis of alkali feldspar or plagioclase feldspar. For example, 2 mica plagioclase gneiss or muscovite biotite alkali feldspar gneiss. The prefix ortho or para suggests its derivations from igneous or sedimentary. Parenthesis, as temperatures approaches 500 to 700 degrees centigrade, very hot but below the typical melting temperature of the rock, the minerals in cystose recrystallize and segregate into layers dominated by one mineral type. The extremes of heat and pressure destabilize the more felsic minerals, breaking them into ions that readily migrate within the rock and recrystallize in distinct light colored single minerals types containing large grains of more stable felsic minerals such as quartz or feldspar. Meanwhile, ions freed from other minerals such as biotite, amphiboles, and pyroxenes from intervening layers of dark mafic minerals. This process of mineral separation is known as metamorphic differentiation. The distinct layering of dark and light color minerals is referred to as gneissic bendings, a striking form of foliated layered textures. When looking at layers rock in the lab or in the field, we contain not to mistaken gneissic bendings for layering in sedimentary rocks. These are two very different processes and textures. The two main differences that sedimentary rocks layers are rarely separated into separate minerals from each bands, a characteristic of gneisses, and that the texture of sedimentary rocks is typically one of individual grains with cements in the spaces, not the interlocking crystalline texture of gneissic bends. Organ gneiss. Gneiss containing abundant porphyroclast enveloped by the foliation to give the appearance of eyes, organ in Germans. Ganulites. A granoblastic rocks that is rich in quartz and feldspar and almost devoid of hydrous minerals. Lenticular to tabular composition layering may be present. Granulites are equivalent of acid plutonic rocks, but those containing quartz, perthite, potash feldspar, and hypersthene are referred to as charnockite. Amphibolite, a dark colored rock composed principally of hornblende and plagioclase, usually with quartz and epidotes. Foliation due to alignments of amphiboles prism is less conspicuous than in cyst. The qualification ortho and para suggests its derivation from igneous or sedimentary rocks. Eclogites, a dense but rare rock of basaltic composition whose crystallization at very high pressure and temperature gave rise to an assemblage omphacite, solid solution of dapsite and jadeite mainly, and Mg-rich garnet with no plagioclase. Common accessory minerals are quartz, kyanite, amphibole, geosites, and rutile. Hornfels, a very fine grained granoblastic rocks which has a blanked appearance similarly to a clink fired ceramics. These rocks are dense and compact and flittering looking and form at high temperature and low pressure by contact metamorphism. Granophytes are non-schistose rocks characterized by isotropic granoblastic textures and mean grain size more than 0.1 millimeter. If less than 0.1 millimeter, the metamorphic rocks called hornfels. Marble, a crystallized carbonates rocks composed of calcite or less commonly of dolomite. Serpentinite, a green, black or reddish rock composed dominantly of serpentine, antigorite, crystallite, etc. It is formed by hydration of igneous or metamorphic petrotites, olivine-rich ultra-basic rocks. Soapstone, magnesium rocks, a petrotite or dolomitic limestone composed of talc with minor carbonates, chlorite, and tremolite. Like serpentinite, the soapstones are also formed by metasomatic alteration of the protolith. Skarn, a granoblastic rocks that is rich in calcium silicate minerals such as gracilorite, andradite, epidote, dapsite, vesuvinite, and wollastonite. The small amount of carbonate distinguishes skarn from marble. Skarn formed by CO2 metasomatism at contact of limestone, an igneous intrusive body, usually of granitic composition. Skarn contain trace elements of economic importance like molybdenum and W. Quartzite, a monomeric rocks composed predominantly of quartz and shows granoblastic texture. Impurities in original protolith sandstone may form aluminous or ferromagnesium minerals. Migmatites, a megascopically composite rock made up of biotite rich dark bands and quartz feldspar rich light bands, which appear to have formed either by metamorphic differentiation or by partial melting in high-grade metamorphism. Several types of migmatites are distinguished depending on the mutual relationship and geometric shape of the dark and light bands. Less familiar rocks, leptinite, used mainly in France, a light colored metamorphic rock consisting of quartz feldspar without mica, but may contain a notable amount of garnet. Leptite, used in Sweden and Finland, a compact, fine-grained, granular metamorphic rocks of granitic composition. It is composed of quartz and feldspar with subordinate mafic minerals. Heliofinite, used in Sweden, a compact, fine-grained, granulose rocks of horny aspect, often banded. Its mineral constituents are quartz, feldspar, mica, and chlorite. Persinites, a green schist rich in poikiloblastic assemblage of albite and epidote without amphiboles and chlorite. Kingsite, a garnet-rich quartz poor mica gneiss with graphite plus minus corderite, sillimanite, and spinel. Chondrolite, an almost massive mica poor or free sillimanite garnet quartz feldspar rock, mostly with graphite as accessory minerals. Garnet and sillimanite together exceed feldspar in modal amount. Charnockite, a hyperthin bearing granite. Grayson, a neometallitic or metasomatic altered granitic rocks whose feldspar is replaced by mica and often rich in fluorine bearing minerals like topaz, etc. Note, if a metamorphosed igneous rock is still persists its original fabric, the prefix meta is used, for example, metabasalt or metadiorites.